Hello, today we are going to learn reinforcement learning in machine learning. Reinforcement learning is a type of machine learning that enables an agent to learn through trial and error interactions with an environment. It involves an agent that learns by taking actions in an environment to maximize a reward signal. Reinforcement learning has been successfully applied in various domains such as robotics, game playing, and recommendation systems. Agent: the entity that interacts with the environment and learns by taking actions to maximize a reward signal. Environment: the external world in which the agent interacts and receives feedback in the form of rewards. Reward: a scalar signal that indicates the desirability of a state or action. Model-based RL: the agent has a model of the environment and uses it to predict the outcome of actions. Model-free RL: the agent does not have a model of the environment and learns directly from experience. Value-based RL: the agent learns a value function that estimates the expected future reward of a state or action. Exploration: the agent tries new actions to learn more about the environment. Exploitation: the agent uses its current knowledge to take actions that are likely to maximize rewards. The exploration-exploitation trade-off is a crucial aspect of reinforcement learning. A policy is a mapping from states to actions. In policy-based RL, the agent learns a policy directly without estimating a value function. Policy-based RL is useful in high-dimensional and continuous action spaces. Q-learning is a model-free, value-based RL algorithm. It learns a Q function that estimates the expected future reward of taking an action in a given state. Q-learning uses the Bellman equation to update the Q function. Deep RL combines deep neural networks with RL algorithms. It has achieved breakthroughs in domains such as game playing and robotics. Deep RL algorithms include deep Q networks, DQN, policy gradients, and actor-critic. Reward engineering: designing reward functions that encourage the agent to achieve the desired behavior. Exploration-exploitation trade-off: finding the right balance between exploration and exploitation. Generalization: making the learned policy applicable to new environments. Robotics: reinforcement learning is used to teach robots to perform complex tasks. Game-playing RL has achieved superhuman performance in games such as Go and chess. Recommendation systems: RL is used to personalize recommendations for users. AlphaGo: deep RL algorithm developed by DeepMind that defeated the world champion of Go. OpenAI 5: a team of 5 RL agents that defeated human professional players in the game of Dota 2. DeepMind Control Suite: a benchmark suite for continuous control tasks that has been used to evaluate RL algorithms. Multi-agent RL: extending RL to scenarios where multiple agents interact with each other. Meta-learning: developing algorithms that can learn to learn. RL for healthcare: using RL to optimize treatment plans for patients. Reinforcement learning is a powerful paradigm for teaching agents to learn from experience. It has been successful in various domains and has achieved breakthroughs in game playing and robotics. Challenges in RL include reward engineering, exploration-exploitation trade-off, and generalization. Thank you for watching us. Stay tuned for next video.